This DeBacco University video, I'm going to go over how to properly measure temperature and also make you aware of some temperature units that you may not have heard of before. All right, let's go over how to properly measure temperature. So first off, the thermometer we're probably using to measure that temperature, we want to prevent it from touching the container. This is an error I see quite a bit. People just put it in and they take the reading. Well, that probe is coming in contact with that surface, so that can cause some particular issues there. So you want to make sure it's kind of, quote, free floating, not touching the container in that liquid to get an accurate measurement of the temperature of that particular liquid instead of the edge wall of the container. This is of particular importance if you're using the container on a hot plate or an ice bath. You want to make sure you're getting the liquid temperature, an accurate measure of the liquid temperature, not the container that liquid is in. All right, so units of measure used for temperature are very important. Fahrenheit, Celsius, and Kelvin are probably what you're most familiar with. Water boiling at 212 degrees Fahrenheit, 100 degrees Celsius, or 373 Kelvin. And you can see the freezing and the absolute zero temperatures. What makes it unique is that Kelvin is zero at absolute zero. When molecules stop moving, that's called absolute zero, and that's 0 Kelvin. If we're looking at the Celsius scale, that would be negative 273 degrees Kelvin or negative 459 degrees Fahrenheit. So the units you're using are very important. Now, there's more than just the Celsius, Fahrenheit, and Kelvin. There's also Rankine, which is an absolute scale that's related to Fahrenheit, and there's Réaumur, which is based on the scale at water's freezing and boiling points. And we can see they're corresponding here for our body temperature, boiling, room temperature, freezing, and absolute zero, probably key points we're most familiar with, and you can see how these different units all compare. So while it might be the quote-unquote same temperature, we could see that those units have very different numbers, so knowing what unit you are using is very important. So why use Fahrenheit? Well, mainly from historical reasons in the following countries. You can see here, United States, Liberia, Cayman Islands are just to name a few that are still using Fahrenheit. And why would you use Celsius then? Well, it's widely used across the world there. It's based on the freezing and boiling points of water. It's pretty much the standard unit for temperature within the metric system. A lot of thermometers may have both Celsius as well as Fahrenheit on opposite readings, so you can get an idea of whatever unit you're most comfortable with. Why would you use Kelvin? Well, in science, it's great for mathematical equations because there's no negative numbers. It's called an absolute scale as well. This makes calculations much simpler, follows the same increments as Celsius, and a lot of the times it is needed to be used to convert whatever you're measuring into Kelvin. Now, this joke here about the Kelvin temperature scale, Lord Kelvin, our scale is being used to a great degree. Good, but don't talk about degrees. It's not degrees Kelvin, it's just Kelvin temperature. Now, when we're looking at Rankine here, we're looking at an absolute scale, very similar to Kelvin, but uses the Fahrenheit-based increments. That's kind of where it derives its originality from. Used primarily in engineering in the United States as well as United Kingdom. And then this Réaumur here is kind of outdated, not really used a whole lot. It's more of a historical temperature. Water does freeze at 0, but it boils at 80. Once was widely used, but it's been pretty much replaced either by Celsius or Fahrenheit in different regions. We did want you to let you know that it exists because units are important with anything, but we can see here the importance with temperature.